Assalamualaikum.
Assalamualaikum.
How are you
How
there?
are you, brother?
Apa kabar?
Alhamdulillah.
Alhamdulillah.
We are still wait. We are still waiting for the others to join us.
Yeah, no problem. My Mr.
Okay.
Benamar is in the airport now.
Oh,
Uh,
okay.
yes,
But
so he
can
looked to
he
find.
can he join the Zoom?
Yeah. He told me he looked for a place to start the meeting. Okay, with us.
Mm-hmm.
Okay, because there is
Okay.
a strike in the morning of about the taxi. Okay, so why he go early to the airport?
Yeah, I think it's safer to come early to the airport than to be late because of the Zoom.
Yeah. I will call him now to ask him if he find if he how to call if he don't I can start first and he can start after me. It's okay.
Yeah, it's flexible. It's up to
Yeah,
you.
yeah.
Just
Because
yeah.
because he told me he look for a place now to make the connection and to make
Oh,
his
okay.
presentation possible. Okay.
Yeah, it's up to you.
Okay. Thank you.
Which one is better for both of you?
Yeah. No, it's okay for me. I can start.
Yeah.
So
It's not so formal
yeah.
meeting. It's just talking and sharing knowledge and experiences.
Yeah, that's true. Yeah. This summer I cannot be in Jakarta
Oh, why?
because I don't know if I can say that because maybe I wait for a baby in the summer.
Oh, I see. Okay. We have like international conference on October. In October,
Yeah.
maybe we can you can come to Bandung. The event will be on in Bandung,
Mm-hmm. It can be
October 15.
October 15. Yeah, it can be done also online or only in physical way in
Also
present way.
online. Yeah, also online. I think. Yeah.
I like to share it with some of my colleagues, like in Portugal, in China. If you like, we can invite more people. Let me know.
Yeah. Okay.
Let me know
I will.
because
I will. Yeah. I will tell you later about the details.
yeah, okay.
Be right back.
Okay, maybe we can start this BRIN environmental talk today while waiting for Professor Tarzan to join us. Good afternoon, everybody. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. We are very glad to welcome you to join the environmental talk of BRIN this afternoon. So we will have two experts from Le Havre University, France, Associate Professor Ahmed Benamar, and also Dr. Ammami, Tahar. Sorry for misspelling your name, pronunciation your name. So the topic of this talk is about remediation technology for sustainable resources management in land and water body. While waiting for Professor Tarzan as the moderator, let me replace as the master of ceremony today. So we are going to open this this event with the opening speech from Mr. Aryo as the head of our research center for environmental technology and clean technology of BRIN. Please, Mr. Aryo, time is yours.
Okay, thank you very much, Dr. Anis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Very good afternoon and greeting to everyone. It's my great pleasure to welcome all of you to the 43rd edition of our BRIN EnviroTalk, a scientific forum initiated by our research center. And this forum is a platform to strengthen the contributions of our research and innovation in addressing environmental challenges, especially in supporting the recovery and improvement of land and water body quality through advanced and sustainable remediation technologies. So as we know, our today's topic of BAT is remediation technology for sustainable resource management in land and water body. We know for sure that today's topic is very timely and relevant as we face increasing pressure on environmental resources, particularly due to the pollution, degradations, and climate-related impacts. So we are very honored to host two distinguished speakers from University of Le Havre, Normandy, France. First one is Associate Professor Ahmed Benamar, who will present on internal erosion on embankment dams. Very good afternoon, Dr. Ahmed Benamar. And the second one is Dr. Ammami, Mohamed Tahar, who will deliver a talk on electrokinetic remediation of dredged sediments, effect of storage and cyclochemical transformations. So these two topics reflects not only the importance of technology advance in remediations, but also the need for deeper understanding of geotechnical and chemical processes in managing land and water system effectively. So we also sincerely hope that this event will spark meaningful exchange, inspire our research directions, and foster collaboration between researchers in Indonesia and France, as well as other countries. So I would like also to extend our appreciation to the moderator, today's moderator, Dr. Hanis and Professor Tarzan, and to all of participants who have joined us today, whether via Zoom or maybe via YouTube. So let us make the most of today's discussions and continue working together toward a more sustainable and resilient environments. So thank you. Wassalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Hanis.
Waalaikumsalam warahmatullahi
Very welcome,
wabarakatuh. Thank
Dr.
you.
Mohamed.
Thank you very much, Mr. Aryo, Dr. Aryo.
Dr. Hanis.
Is Professor Tarzan here already? Hello, Professor Tarzan.
Yes,
Where are you?
I am.
We are very sorry if there is some trouble with the connection. Sometimes there are trouble with the connection in BRIN. So please
We have the same
understand.
problem sometimes, yeah.
Yeah. Okay, let's continue our event. Professor Tarzan will lead us as the moderator for this talk and the presentation. The first one will be the presentation from Associate Professor Ahmed Benamar. Please, Professor Tarzan, please lead us as the moderator. Time is yours. Thank you.
Okay, thank you, Dr. Anis. Excuse me, it was trouble here by me. So, I hope our meeting today would be success. So I would like to share the timetable for today.
Excuse me, Professor Tarzan, because Professor Ahmed Benamar will fly to another country or another city. Maybe we can take the picture before starting.
I think you take picture better.
Okay, I will take the picture. Everybody, please open the video. Maybe while Professor Benamar still here. Okay, please open the video. Everybody, the first page. I will take the first page. Okay. Okay, the second page. Please smile. Okay, the last one. Smile, cheese. Okay, thank you, everybody. Please continue, Professor Tarzan. Thank you. Excuse me.
Okay, thank you, Dr. Anis. Can you see my slide now?
Ya, Ded.
Sama berarti.
Okay. The first presentation today is from Professor Dr. Ahmed Benamar. Professor Dr. Ahmed Benamar is lecturer in the Havre-University in Normandy. His education was in 1985 from civil engineer in Algeria, in 1988 Master of Science in École Centrale University Nantes, France, and his PhD in 1992 in civil engineering, also from Nantes, France. His presentation today is internal
Excuse me,
erosion.
Professor Tarzan. We cannot
Hello?
see your screenshot. We cannot see yet.
You cannot see?
Yes, not yet.
Not yet.
Maybe I can help you if the internet in your place is not good. Maybe I can help you to share the screen.
Hi everyone.
Can you see it, everybody?
You hear me?
Yes.
Hello? Hello?
Yeah, I can hear you, Professor Benamar. Can you see my share screen?
Hello?
Hello?
Hello? You hear me?
Yes, we hear
Yes,
you.
we hear you.
Yes, we
Yes.
can hear you.
Yeah, just take place.
Apply to your cell phone, Ahmed.
I think the connection is right.
Yeah, you are in the airport, right?
Yes. He's in the airport now.
Professor Tarzan, I have seen the CV of Professor Benamar. Maybe you can read it shortly. Profesor Tarzan masih di dalam, guys. Where is Professor Tarzan? Maybe the internet is not good over there. Yeah, I think. Yeah, okay. I will help him. Professor Ahmed, Associate Professor Ahmed Benamar from Civil and Sustainable Engineering Department of Le Havre-University, Le Havre-Normandie, France. Sorry for the mispronunciation. Okay, the education from the Algeria for bachelor degree and Master of Science from Dynamics and Civil Engineering École Centrale Nantes, France, and also the PhD in 1992 from PhD in Civil Engineering from École Centrale Nantes, France, with the thesis title Experimental Study of Lateral Friction of Piles During Driving in Clay, and also the Associate Professor in 2013. His research about porous media and geoenvironmental engineering, and his lab is about the head of sediment research group in lab. Okay. He also teaching with different subject: geotechnics, construction technology, reinforced concrete, soil remediation, environmental geotechnics, and so on. Okay, for saving the time, maybe we ask Professor Benamar to start the presentation. The time is yours.
I guess his connection.
I will stop the session. Yeah, thank you. I can see it.
Okay, I will present today the issue of the internal erosion of dams. So this topic was investigated since 2 decades. So it was about what can an embankment managed in a dam can be eroded by seepage. So here there's a picture about solid dam where we see the embankment, the pool, and the filter. So the erosion can occur in the embankment, but always in the core or in the interface between the filter and the core. So what we have to also investigate the interaction between the filter and the core. Because many fiber particles can be eroded, and so it can be linked to the dam collapse. There is so four mechanisms of internal erosion identified by the International Committee of Large Dams: the backward erosion, the concentrated erosion, the contact erosion, and the submersion. We were dealing in our research studying the submersion process, but we are starting to also investigating the contact erosion. These pictures are about many incidents which happened over the world on dam collapse. The famous one is the one occurred on Teton Dam in 1976. Was the most documented incident of dam. The acting parameters on the source of distribution, many criteria were assessed by many researchers: hydraulic load, applied stress, creation, water chemistry, compaction, fines, flow direction, and also heterogeneity. So the most known criteria is that of Bersih and also they are also still used in the research. Many available tests, standardized tests, are available also for characterizing the erodibility of soil. How erosion is tested for originally it was assessed for the investigation of soil dispersivity, but always it can be used for erosion characterization. Second one is the jet erosion test. This jet test was mainly used in the US. It was dynamic hydrodynamic tests, and there are many criteria in classification for this test to identify erodible soils. How submersion process occurs and develops. So we can do that by experiments or by modeling. The mechanism that involves the selective erosion of fine particles with the porous matrix of also soil particles. Here, the picture of submersion process in a porous matrix. Submersion is both processes, particle detachment and extransport through the porous material. So we have investigated the conditions, the granular conditions of the tested material, the hydraulic under which submersion is set, parameters governing submersion kinetics and their influence, relationships between submersion parameters and physical characteristics of soil material. Submersion is an internal erosion process where finer soil particles moved through constrictions between larger soil particles by seepage forces. When the internal erosion initiates, we also be aware about what he can develop and what is the kinetics of this process. So coarse-grained soils, non-cohesive soils erode more rapidly than fine-grained soils. That's experimented in the lab and have lower temperature stress. In literature, much focus has been placed on the potential of mineral stability and therefore investigation of the geometry. I just presented here a study about several sources of perspective from America, which is susceptible to internal erosion in laboratory. So for testing this soil, we just many words about this dam, Chess water dam in Western Grad. It is a node dam, and one pathology was discovered 1 decade before on one embankment, and the water seeping through this eastern embankment of the dam. So the investigation was performed in our lab about many cores collected in this embankment to quantify the dam's resistance to internal erosion. And so the suggested solution for this pathology was these scent filters that will trap the smallest particles, supplemented by relief wares. This is a picture about samples collection. These are the cores which were provided by Fegro company. This is the geotechnical cross section of many cores. So we did investigation on many or 6 samples to investigate how it can be eroded under any stage. This is the picture of the setup in lab. We just inject seepage an upward flow through the soil, and we collected the particles, eroded particles, which were quantified by the turbidity meter. So we investigate hydro condition under resource fusion in cells. So the threshold value of hydro gradient or shear stress, which start to initiate erosion or suffusion in that soil. So also identify the K parameters governing suffusion and quantify their influence. The procedure for this test was to increase the loadings, still significant outlet turbidity occurs. From that results, we attempted to give an overview of what each sample was more erodible than others. So it's here the typical turbidity signal recorded, and from that we get the mass loss from turbidity measurements, the eroded mass. We got the critical gradient, hydrologic gradient, under which erosion initiates. And from this all this data, we can also, here we just have pictures about testing and what happens when there's no suffusion. For example, here there's no suffusion, and but when increasing the load, there is uplift, an uplift. From all results, from all data, we can characterize the erodibility of soil by drawing this parameter, erosion rate versus hydraulic shear stress. And so from this linear trend, we get a coefficient, erosion coefficient. This erosion coefficient, the erosion coefficient is used to assess if any soil is more erodible than others. Here we have the hydraulic versus applied hydraulic gradient. So we see here that for this sample, the first one, we have the increase of hydraulic gradient very early, the process of subjecting the sample to higher seepage. So this sample is resistant against erosion. This I say that there are many criteria in the literature assess thermal stability from this test. So this one is combined Kenny and KSD criteria. Is mainly used by engineers. So from that, from the data obtained from our test, we can test this. We can assess if any sample is prone to suffusion. So here we have many samples. We have here this instability in this zone. This is the area where all these samples are unstable, so prone to suffusion. From all data, we assess to address this table, which give the stability state of each sample. So from that study, the erosion begin in intermediate stable source at a gradient lower than units. So they are so far from the criteria of Tarzan. Yes, Tarzan stated that the critical hydraulic gradient to thermal erosion is close to 1 to the unit, but in many studies about thermal erosion, this critical hydraulic gradient is lower than units. A discrepancy between experimental and theoretical values of critical hydraulic gradient may be attributed to the force of disturbance when we analyze our experimental results with the criteria, the result of many criteria like that of Kenny and KSD. So there is many discrepancies because maybe that criteria were addressed for specific soils, which can be quite different from our tested soils. A gap-graded soils began at lower gradient than well-graded soils. This is known that well-graded soils are more resistant. Soils with more than 30% fine content may not be adequately assessed by usual criteria. Some samples tested to be stable are deemed to be stable by used methods, but that used methods were, I think, were assessed for quite coarse soils. We tested fine soils like core, damp core soil. This criteria is not suitable. In laboratory testing, we also tested the effect of fines type on the erosion or susceptibility to erosion. We used many mixtures of sand with fines. As fines, we used either carbonates or silt islet. So we these are the characteristics of the different materials. So, what's the effect of clay type on fine subdivision? So, from that results, we made many conclusions about the erosion kinetics of these mixtures. But when we used, for example, 5% of fines, so the silt is, the erosion of silty soil is very rapid, and the erosion in mixture with kaolin or highlight, so the erosion is for the moderate. So the silt can be more erodible in soil mixture than other fines. So the potential of instability is provided by the proportion of fines. Silt mixture are more suitable to suffusion than highlight plants. Sand alike mixture is the last erodible. The light is a clay which is the most resistant to suffusion. More fines are added in the mixture, the less the relative eroded mass. So when you have a soil with, it is known in the engineering practices that when the fine contents in the soil is more than 20%, it starts to be stable against erosion. Halite is a group of closely related non-expanding clay layers, and they are able to absorb more water than carbonates. That's why it can be more resistant to erosion, and also in dispersive tests, halite is the less dispersive one. Chlorite is known to be more dispersive than halite. So another investigation campaign was held on coarse soil. This coarse soil was collected from Rhine dikes in eastern France, on the border with Germany. This soil was tested in a large setup because it contains coarse grains up to 14 millimeters. Yeah. This was a polygraded gravel, mainly gravel. So we tested its stability using literature criteria like the Van and Fel, the yeah, the last criteria assessed by BRIN EnviroTalk. So we also compared our soil to other tested soils in the sure. So our soil seems to be stable. This means, and in many situations, it is transition zone stable. But when we use the Kenny criteria, the low criteria, so the soil seems to be also stable, quite stable against erosion. These are the data collected from the tests. This is turbidity measurements and the water velocity, the hydraulic gradient, tested hydraulic gradients, and the eroded mass from the summer. So this test we got the height from bottom to columns, and here we tested the local gradient. So we investigate how it can occur inside the sample in different locations in the sample when erosion starts, because we can get erosion inside the sample, but no particles wash out. So it is interesting to have this analysis. So we see that the local gradient suddenly increase when we are in the top of the sample. We see in this picture that many fine particles are washed out, but it cannot solidify the Okay, for summarizing these results, tested gravel soil shows quite interesting resistance against suffusion till hydraulic gradient close to 1. The suffusion kinetics is low because the erosion coefficient is 10 minus 3, leading to its classification as moderately erodible soil according to FEL guidelines. The particles migration in the cell is highlighted. So by the decrease of hydraulic gradient on the upper side of the sample, the suffusion is more effective in the downstream of the sample, and the cumulative eroded mass represents a ratio less than 1% of the total erodible mass. Or eroded particles are fine, and only very low percentage was eroded. So how we can say that our soil is deemed to be stable against erosion. So I also said that we tested the filtration. Filtration is important in the zone labs because the filter allow to retain particles eroded from the core here. So when there is a crack in the core, fine particles can be eroded by CH, but the filter can retain these particles. It is the action which is needed from the filter. There's here from this is the picture we selected our filter according to this limits here, gradient limits. Okay, and I just give 2 words about suffusion modeling. Also, try to model this process in soils, we use this equation, convection dispersion equation, with the variation of the concentration of ice in the soil as a result of erosion. So the dispersion can be neglected, and we can simplify the equation to give analytical solutions. Here is matching results between experimental results and numerical data. So we can see here that we can modelize with that process, that physical process of convection and fine detachments, can modelize efficiently the process. For my conclusions and the studies and the questions, the potential of stability is governed by the fines content and mainly by the type of clay. Highlight is the most resistant against corrosion, and silt mixture are the most suitable to situation. Sufficient kinematics was also highlighted. Migration particles toward the downstream were pushing the curves. There's the rise of high pressures. Grain shape affects filtration process. Suitable evaluation using provided erosion filtration test can be interesting. A good agreement between model results and experimental data from this fusion of ice provided for a single hydraulic flow, but less accordance is paid for more than a single line. So because when we apply only successive rules, we don't take the same initial conditions. So in the modelization, there's quite a experimental results. Thank you for your attention. Sorry for this disturbance from the airport.
Thank you, Professor Benamar. Now we have time for discussion. How much time you have for your flight?
How much studies? I think from since 2008 or maybe five, so 20 years ago we started investigation of this process in soils. So we performed many studies on. So, is it
okay?
Sorry, is it your question?
I think he's asking you about how much time you have left before your flight.
Oh, no, sorry. My flight is in 1 hour.
Oh, so you have still enough time.
That's
for
not
discussion.
Yeah.
Yeah.
I was arrived the morning, early morning, because there was a strike of taximen in the airport. So they broke it. I think they are blocking now the airport, the access to the airport. So I wake early morning to take
Okay.
bus to go to come to the airport. So that's why I'm early. Any question or
Yes,
anything?
our ladies and gentlemen, now is the time for you to ask Professor Benamar, you can raise hand or write your question in the chat. Okay, there are question in the chat. I would like to read it. Dear Prof. Benamar, thank you for the additional insight in this presentation. On a larger scale, a river basin area, how do we know the source of sediment, the age of sediment that is sedimented, and how to track the time length the sediment has been eroded, and the effect of the chemical composition of the interstitial fluid? Thank you. You may answer, Prof. Benamar. Can you get it?
Professor Benamar, you can read the question in the chat. Yeah.
Okay. Yeah, the timeline. Yeah, in the lab we are limited in testing soils, so we usually tested our columns for 8-10 hours, no more than, because there are limitations in the lab access and so on. But I think when we start getting the erosion in the soil, and if this erosion was decreased, and when the turbidity remains very low during a long time, maybe 1 hour. So under constant hydraulic conditions, we assume that no turbidity later can occur, but maybe we think maybe we have to test soils for many days, but no change in the susceptibility of a soil to erosion can occur after that testing time of 8 hours or 10 hours. For your question about the settling, yes, settling particles, particles can settle in the process of erosion. We can also assume that particles which are settled can be detached again from the matrix when the hydraulic condition change. So that process can be modelized also, because we can use the equation of convection, detachment, deposition, and remobilization. It's complex, but it can be done. Chemical effects. Yeah, we also investigate the chemical effects. Because the water reservoir can change. So we tested the salinity, mainly the salinity of water, seepage water. So when salinity increases, the erosion decreases. The soil was more resistant against erosion. Okay.
Okay, thank you for your answer. I hope it meet the second question from Rizky Pratama Adi. Good morning,
So this
sir.
is
Rhine
showing
River
that
is one of the cross-border rivers in Europe. I am curious to know how the dam construction along the river had contributed to the increased river bed erosion, which also related to the policy of each country. What are the long-term implications for river body and its sediment transport? Also, is there any transboundary issues happened recently in Rhine River between France and Germany? Thank you.
yeah. So I think we in that works we investigated the internal erosion. Internal erosion is a process occurring inside the matrix, soil matrix. But what you mean about erosion in rivers, surface erosion, it's another process with other conditions. So,
Okay.
We're also skating that process. Erosion in a frame. We're now testing erosion of corrosive source in a flow. Maybe we'll take results, which I would be happy to present next time.
Okay, the third one is from Jayanti Mary. Dear Prof. Benamar, thank you for the very insightful presentation. Based on the results showing that the tested gravel soil demonstrated strong resistance to subversion, how do you see the potential application of similar materials in small-scale embankment of dam located in landslide-prone regions such as in Indonesia? Would subversion characteristic alone be sufficient as a primary basis for selecting local materials?
So it's really
apa mencontohin lah jadi pedagang atau buat pabrik itu, apakah jadi bisa betul ya? Karena mencontohi, oh itu nggak bisa.
I can answer. Can I answer?
Yes, please.
Yeah, from the testing scale, it's a regular, it's a permanent question. How to test in lab soil and how we can use a lab results to scale to the field pathologist issues. So but what we do in lab is to make the similarity. But in many labs, we also combine lab testing with field investigation, auscultation or investigation. That what was done on the British dam. So many investigations were made on the dam, and they also took our lab results and they make a final decision about how to repair the dam. So this, the problem of the testing scale is very important, but we cannot. At now, we cannot make investigations on the dam because we take informations about the owners when it is available. Thank you very much. I think I have to reach the gates for my flight.
Okay, thank you,
Excuse
Professor
me.
Benamar. Although there are one more question, but your time is limited. We thank you for your presentation for today. We hope we can have another better time for next presentation. I thank you, Professor Benamar, and all of attendee for the presentation of Professor Benamar. Thank you.
Thank you very much. Good. Bye-bye.
You're welcome. Bye-bye. Have a nice flight.
Thank you.
Okay. Now, after Professor Benamar, we have the second presentation from Dr. Ammami Muhammad Tahar.
Yeah.
Can you see my slide?
No. There is no
No.
slide sharing. Yeah.
There are no slide. Okay, maybe it's also
Yes. Yes, I see that. Yeah.
okay. I would like to read first the CV of Dr. Ammami Muhammad Tahar. He's from Tunis. His education BSc in Science and Technology, also Master of Science from Geotechnology and Environmental Engineering in Tunisia. He has also Master of Science from Science in Engineering and Civil Engineering in PhD from Le Havre-University, France. He is now a head of Department of Civil Engineering and Sustainable Construction at University Le Havre-Normandie, France. He is teaching also in the Faculty of Science and Technology, University Le Havre. Dr. Ammami Muhammad Tahar. Now, the time is yours to present your presentation.
Thank you, sir. I will like to say Assalamu alaikum first. I'm so
Walaikum
proud
salam.
I'm so proud to
Waalaikumsalam.
be I'm so proud really to be part with this event. Thank you for Sister Hanis Barasari for the invitation. And
You're welcome.
I'd
It's
like to share.
our pleasure.
Yeah. Thank you. I will try to share my screen. Partager. Presentation. It's okay?
Yes, we can see it.
Okay. Reduce this a little. Yeah. Okay, so for today, I will talk a little bit about some activity in our lab, and this activity it's about remediation of materials or contaminated materials. My presentation will talk about effect of sediment storage condition on electrokinetic process and metal removal. Um, I will divide my presentation in different level. First of all, I will talk about the main problems we have in our city here. So I will talk about the dredging activity. This activity, it's a vital activity for the harbor and any canal maritimes. And usually we use this activity to maintain any condition of transport in maritime area, to develop any facility for the harbor, and it's also can help to create a new site, for example. When we talk about dredging in France, we count 50 million cube meter in sediment by in average every years in maritime sediment. But about river sediment, we count 6 million cube meter in France. And this activity, it's a huge activity and generate amount of quantity of sediment. Second point, it's about our area. Le Havre city, it's portuary city, and we have the first harbor in France about container transport. And the connection between Le Havre and Paris, it's around 2 hours. But we have a river. This river is the name of Seine. He help to maintain the economic issue when we bring container from Le Havre to Paris. When we talk about maritimes, usually we talk about dredged sediment, materials, and how we maintain this activity. The problem when we dredge materials, we have a new standard every year comes. For example, if I give a global thinking about what happened here, usually 95% of the sediment we clamping in the sea. And this rules, it start to become more difficult because the standard years after years, it's become more strict. And we estimate the 5% from dredged sediment. This sediment, it's contaminated and we don't have any permission to clamping in the sea. So we need to have some kind of solution to deposit in some temporary storage these materials. Our harbor here in the city, he count 3 million square meter of dredged sediment every year. So we have really a lot of amount of materials. We deposit in some specific area. This specific area, it's become more busy and we need to look for some kind of good solution to reuse the materials. Everything is good? I can keep?
Yes.
Okay.
Please continue.
Okay. There is another kind of problem in France. It's about the number of a huge number of sites polluted by heavy metals and carbon and pesticide. And we count more than 700 sites. This site, it's need to be treated in France. So when we look for these two information, we have a lot of amount of sediment contaminated, and we need to find a solution. Second part, we have 7,200 sites need treatment also. So remediation is something we need to focus to fix the problem for this kind of materials. And like a lab in civil engineering and environmental science, we think carefully how to fix the problem and how we can make these materials be used in construction area. So we choose a method to remediation for remediation. This method is electrokinetic process. And why we choose this method? This method have a good advantage. I will explain that why. But how it's work, this method. When we apply electricity, any field electricity in the soil, we destroy first the electron neutrality of the medium. Means the balance is destroyed and we will generate some kind of transport mechanism. The main transport mechanism, we have electromigration, means any transport for any entity charged in opposite side of charge. And we have the electrosmotic flow. The electrosmotic flow, it's the movement of the water depending of the electric field. And it's depend of the charge of the surface. So why we call it electrosmotic? It's a surface phenomena. We have mainly some kind of chemistry reaction, and the most important thing is the electrolysis of the water. Means in the anode side, we will produce H plus. Means it's become more acid close to anode side. And for cathode side, we generate OH minus, and the pH is increase in cathode side. So when we apply the process, we have some mechanism of transport, and I will say the weak point, we modify the pH, means we affect our medium. So we can play a little how to improve our process by adding some kind of molecules. This kind of molecules like we call gelatin agent, surfactant agent, and any kind of acid, it can help or improve the desorption, or the migration of the element. Another element we can modify and we can improve is the power supply mode, how we can apply electricity and how we can regenerate our medium. So for the advantage and why we choose the electrokinetics, we choose it because we can apply this technique directly in the field. And another point and interesting point for us, this kind of treatment, it's good with lower permeability soil, means with fine particles. So if we have a lot of silt or clay, this kind of treatment, it's more suitable to apply. We can use also this kind of technique to reduce the volume of the chamber where we have sediment, means we can improve the dewatering by electrosmotic. We can talk also about the limit energy consumption compared from another process like the thermal process and flushing process. We use lower electrolyte additive. And another good point, we can both work in the metal and organic, means we can look for charge and no charge element in the medium. Our research work, it's how we can use sediment and how we can make the sediment suitable for civil engineering construction. And to reach this goal, we will use two mechanisms, the electromigration, electroosmosis, to reach our goal. The electromigration, it will be applied for any particle have charge. The electroosmotic, it will be applied for any particle no charge or no ionic species. And to make this in the lab, we developed some kind of prototype. And the idea, it's so easy. We have prototype divided in three parts. In the middle, it will be the sediment or the materials part. And in the left and in the right, we will have the compartment of the anodic and cathodic part. So we inject by pump the molecule, and we have an overflow system to have the leachate. And our aim is to inject what we need to modify the physical chemistry parameter in the medium and to to make it more easy to extract element. I would like to start to, when we start to work, and I still remember when we start this subject, we start to apply about the sediment because we have a lot of sediment here, but it's the most difficult to treat. So I will expose here in this figure five experience. The global condition, we apply 1 volt by centimeter, and we will add citric acid like additive, and the treatment is for 3 weeks. So I will invite you to focus more about the experience 1, 2, and 3. And this experience, we increase the concentration of the citric acid from 0.1 mole to 1 mole. And what it's interesting, and what we find it and we publish it in 2015, it's when we increase the concentration of citric acid, we increase the rate of removal of the element. But it's not always true, because when we reach some critical concentration, like 0.5, there is really no significant difference when we go directly or double the concentration for 1 mole. This is one of results we find it, and we can explain it why 0.5 it's better than 1 mole, because when we have a lot of competitive with the molecule of gelatin with the metals, we lose our aims to extract in correct way the element. Another conclusion we get it's about the intermittent treatment. What means intermittent? We have continuously treatment for 21 days. We apply 1 volt by centimeter for 24 hours for 21 days. The intermittence means we will make activation phase and we will make off electricity. So we will apply for 5 days, and after that we apply for 2 days off. And what it's make it interesting, the experience 4 compared for the experience 1 is the same condition, the same concentration, but we change the modality of the electricity, and how we show we can improve the removal of the element. And what we get like a conclusion for that, when we have the medium and we treat the medium or the matrix, we treat it. So when we activate the electricity, we are in activate mode. We have electron migration, we have the pH change, we have like a dynamic in our cell. But when we go to off mode, we have the mode, it will be designed to release element. And it's more important, because if we can understand the dynamic of the intermittence, we are able to optimize the treatment and reduce the energy consumption and to improve the treatment. Another conclusion we find it's about the pre-treatment. So before to start the process, we try to add with the matrix, and we mix it. We add the citric acid with 0.1 mole, and after that we start our treatment. But what it's make it complicate when we find the condition or the pre-treatment not affect really the reduce of the metal. I will say only zinc we have more than the experience 1, but really it's not significant. So pre-treatment is not significant in our opinion. The same case study with sediment. This time we focus about the polycyclic aromatic hydrocarbon, and we focus about the priority 16.1 fixed about the risk of the environmental. I will start with, here we use surfactant, it's 2 in 20. It's no ionic surfactant, means we are able to extract this kind of organic with electroosmotic without any charge. So, and we use 5 times the micellar concentration. Why? Because our aims is to make a missile like this. The organic, it will be fixed in the middle, and after that by electroosmotic flow it will be transported until the anode or the cathode, and like this we can extract it. And some of the result, in my opinion, it's give us a good idea about the process. First of all, we are able when we increase the electroosmotic flow. So this is why it's important, because even we increase the concentration of citric acid, the element change or the process change is the electroosmotic, because when we add more molecules, we make the conductivity better about the citrate itself, and when the electricity is better, the conductivity is better, the electroosmotic it's become better. And we can see from the experience 1, 2, 3, the electroosmotic flow increase and the rate of removal increase until to reach more than 54% of removal. So electroosmotic flow, it's so important to extract organic compound. And now we will compare two things, the experience 1, the experience 4. We talk about the intermittent, and the same conclusion like for the metal. We improve the electroosmotic flow and the rate compared to the experience 1 and 4. It's improved. So the intermittent improve the removal by improving the electroosmotic flow. The experience 5 give us another story. Why? Because the electroosmotic flow is not high compared to experience 4, experience 3, but we have, I will say, the best compared for the experience 3. And when we compare between experience 3 and 5, we find the experience 5 don't have the best electroosmotic flow. What means? The pre-treatment improve the removal without improve the electroosmotic flow. And this is give us the conclusion. For the organic compound, we don't need really to start first to improve the electroosmotic flow. We need start first to help dissolving the element first. When the element is dissolved and it's become more mobile, we can apply the electroosmotic flow to extract it from the matrix. I will talk about another case of study, and this study it's happened in 21. It's when we still in the COVID, and this study it's focused about some element in metal and the arsenic. It's happened in some area here in Le Havre city. We have an accident, an industrial accident, and we have a lot of element go out from this area. So the company make a geomembrane to protect this area, and she asked for our help to see if our technique can help to extract the element in easy way. So we make some laboratory scale test, and our aims to achieve quickly and significant reduce of metal concentration. And in this table, I present the concentration we find. So we have cadmium, copper, and we have zinc. And the arsenic, the concentration is so high. I forget to say something. The sediment usually, the content of the metal, it's not high. But when we have any accident about the industry, really the concentration has become more interesting, means the treatment it's become more interesting also. So what we do, we apply the treatment, and we apply a simple test with citric acid and with tensioactive, about between 20. And why we use them? Our aims first to use some agent. It can be friendly for the environmental. It's cheap, and he can help to have good efficiency to reduce the metal. So I show here the removal rate. We find it for different level of deep. For example, the first experience it's the simple from 0 to 1.5 meter. So for cadmium, for example, we reach really completely removal. And compared to arsenic, we find after 3 weeks without any improvement on the test, we find we are able to reduce between 33 to 45% of the arsenic. I like to say something. When we apply the treatment 3 weeks with one or two agent or additive, usually the process is more complicated than this. This experience gives us the idea how it's work, and after that we are able to improve the treatment and to make it more sophisticated to reach better removal. So one of our conclusion from this study, we try to compare between why between sediment and soil is different. For sure, it's different because the story and the bounded connection between the metals, for example, and the sediment, it's more deep because the pollution, it exists for many years, more than decades. But the accident, we don't have yet this kind of strong bound between metals and the particle of soil. I like to say something. The soil, usually there is, or any soil, they have different kind of fraction. So, and depend of the metals, it's in any of fraction, we are able to understand it's easy to get out or not, or to remove or not. And there is a TCA method. It's developed in 86 or 85, and it's used in chemistry, analytic chemistry. We call sequential extraction. So to know the metal in any kind of fraction in our soil. But even without this, we are able to understand with our treatment, because we know the condition, the metal, it will be fixed in any kind of fraction. I will present the last case of study. It's about the storage condition. And this study is still in progress, and we still work on. So I will present some part of the result here. And why this kind of case of study? Why we look for storage condition? Usually we work in the lab with controlled condition. So we start to ask a simple question: how if we apply the treatment in the true condition in outside? In our city, we have different kind of temperature, different weather, and we need to know if the answer of the treatment is still the same or not. So this is the aims, because we work now to improve our treatment, yeah, for sure, but we work also to apply directly on site, and it's apart from our aims for next step. It's to apply for big scale treatment. So in this study, and usually it's our methodology, so we control any change when we treat the sediment. All the physical chemistry parameter we control. We control the electricity, we control the electroosmotic flow, we control the additive we give, the pH, and after treatment, we slide our materials and we analysis by mineralogy, XRD for example. We check the total carbonate, the organic matter, and we analyze it with the XRF, means the content of the metals. And we use this protocol for all the experience. In this table here, I present all the characteristic for the new sediment we use it. We don't use the same sediment. Why? Because the darajat, it's happen periodically, and sometimes when we look for study something, so we need to take the sediment we find, so it can change. It's not the same materials. So here, to make it easy, yeah, for sure we have 5 experience, but usually we will focus about the experience 2 and the experience 4, and to compare between them. Why? Because we like to know what's the effect of the freeze thaw. We make the sediment in the experience 4 and -6 degree. And after that, we start the experience, and we like to see if the freeze thaw can affect really the treatment. Another experience, interesting, is the experience 5. We compare it with 3. And here it will be about wet-dry cycle, because we like to see when we work on site, sometimes we will have raining, sometimes we will have a dry season. So we look to see what's the electrokinetic can be affected or not. So
Ikut.
I chose some
Nah, itu
results.
aku ya dulu matematik kimia. Soalnya tuh guru matematik aku SMA tuh gendeng. Agak gini, jadi ngejelasin tuh.
Can I keep or there's a problem?
Okay, go on.
Okay, thank you. So here I show some result from our study, and what it's make it interesting when we focus about the first figure A, and we control the electricity during the treatment. And here we look for the experience 2 and 4 to see if we will have the same behavior, the same pattern or not. And what we find, the experience 4 have better electricity. What means? Means the fish thaw sediment show to have higher ionic species in the pore water. And this indicated by the higher current. And it's so interesting to know the electricity is not the same. When we say the electricity is not the same, the conductivity is not the same, means the treatment can be different. We will check after with all the parameters we measured. And comparing for the figure B, when we focus about the experience 3 and 5, and here the experience 5 is the wet dry cycle, and we find the voltage it's higher in the experience 5, specific in the beginning of the treatment. So the voltage is high in the experience 5, then the experience 3 in the early stage. And this it can be explained by the lower resistivity we can find, and the conductivity can become higher in the later stage compared to the experience 3 in this part. And what it's make it more interesting, we find all what we see here about the resistivity, the increase of the ionic species, we find it correlated with what we measure in the compartment anodic and cathode about the lithiate. So we can confirm when we have high electricity, we find a lot of the conductivity here, high value of the conductivity. Another parameter, and it's one of most important also parameter, it's about the electroosmotic flow. Usually the electroosmotic flow, it's proportional of the value of the apply of the current. So when the current increase, the electroosmotic flow increase. But it's not always true, because there is another kind of parameter. It's the double layer theory. What means? Means it's not only about the electricity increase can affect the electroosmotic, it's also what happened really in the thickness of the double layer. And what it's make it more interesting, we can compare, for example, the experience 4. It's about freeze and thaw. It's the green color. We can find the experience 2, the red. It's better. So the electroosmotic flow is better. And it's an opposite about the species or the increase of the species. But in the size, we can find we can explain that. Because when we say the electricity increase, means we have more species, means there is some kind of proportionality here. But when it's not work like between the experience 2 and 4, it can be explained about what happened really in the double layer theory and about the thickness. Because when we have a lot of element in the double layer, the thickness change and the mobility of water is become limited. Another parameter measure after treatment, it's about the pH and the conductivity. And typically in the pH we find something similar in literature and what people find. So usually close to the anode we have pH, a lower pH, and in the middle until the cathode usually the pH don't change a lot, but in the global pattern we find our pH after treatment is lower than the value of the initial pH. The conductivity is the same except for the experience 5, the wet-dry cycle. And what it's make it important here to reply for our first question. When we change the storage condition, the electrokinetic parameter change or not? Yes, the impact of storage condition exists, and we can see it for the modification of the pH and the conductivity also. After treatment, we control all the mineralogy by XRD, carbonate also and organic matter. And what we find interesting, the initial sediment had a carbonate content around 30%. And what we find interesting also, the carbonate it's dissolved when the pH is become so lower. So from this two experience here, sorry, we have more than dissolve of the carbonate. And the decrease is caused by dissolve, and the dissolve is caused by the acidic of the pH. But when we check the granulometric size or the distribution size and the organic matter, we didn't find any change for all from anode to cathode. We didn't find any modification. And this is it's one of our conclusions. So the treatment don't affect really the particle size and don't affect the organic matter. Maybe because we use citric acid and the pH is not so acid, okay? So we don't modify our materials. And we are lucky because we like really to show the treatment with this condition don't affect our materials, and it will be easy after to use it for another kind of use, like in agriculture, for example. Concern some element, we check some salt, the chlor, and we look about the removal. And what it's make it important here, and confirm what we find. The condition storage affect the treatment of the electrokinetics. So when we check, for example, for the experience 5 and 4, the removal it's different from 40% from the sample until the cathode area. Another kind of removal, and I will talk a little bit by chlor, because we are so motivated also to extract chlor if we use it for the agriculture use, our sediment. And we show how we are able to extract correctly the chlor because it's so easy to extract, it's mobile element. But what it's make it more interesting when we look for experience 5 and 4 means the storage condition. We find in the anode we don't have the same removal rate. What means it's confirmed what we find. Any storage condition affect really the treatment and affect also the rate of removal of the element. I like to give some conclusion from my job. Our investigation look to better understand the impact of sediment storage condition in the electrokinetic process. And we use different kind of conditions like wet dry test and freeze thaw condition.
Awalnya berat-berat kan.
And the answer, and we apply for the answer when we said, yes, this study confirmed the storage condition affect significantly the parameter of the electrokinetics process. And to say the main point, I will said any modification of the condition, storage condition affect pH. So the true parameter affect the treatment is the pH parameter. Concern the materials, we find carbonate included calcite, dolomite, and aragonite significant affected by the pH during the treatment. For more investigation, we need to perform more to understand, for example, the dissolve of the carbonate, because we have a buffering capacity in the sediment, and it's interesting to keep this buffer capacity to make it easy for us to use. Because the aims when we apply the treatment, we don't like really to modify the medium to become new. It's like we we have in the beginning stage, we have waste materials, we make treatment, and after that we will have new waste materials. So we're still missing some point. It's about the process of the metal release, and if we can connect it with the mineral composition. And there is another parameter, it's the competition between the cation in different condition and what kind of affinity when we change, for example, the citric acid for any kind of gelatin agent, like, for example, EDDS or NTA or EDDS, for example. So there is another kind of point we need to think carefully and to complete our study. Thank you for your attention, and I will be happy if I can reply for your question all.
Thank you, Dr. Ammami.
Terima kasih.
Storage condition. Before we go to the question in the chat, I would like to ask you about the storage condition, aerobic and anaerobic. Do you think the concentration of oxygen has the influence?
Yes. This condition affect the treatment, and during our experience, I didn't show all what we made, but for example, if we take the sediment, fresh sediment directly from the dredge it instantly, and we start to treat it, really we find it's more complicated to make any rate removal. So why we give recommendation for the local authority here in the port to put the sediment first and deposit the sediment and to let this kind of oxygen work. And even it can help about the drainage to reduce some elements. So yeah, I confirm the oxygen work, and how to call it's make it his presence, it make it more difficult, the oxidation about the treatment.
Okay,
So
thank
if
you.
I complete, if
Excuse me.
from 2009, about it's important to put sediment first in deposit area, because the oxidation, we need to reduce this kind of oxidation first. It's make it more easy for us to treat the element, to treat the sediment.
Okay, thank you for the
And
answer.
yeah, and sorry, I will add another. And why? Because it can affect also the speciation. There is two kind of speciation in the sediment. We call chemistry speciation and the mineralogy speciation. So when we keep, for example, in deposit the sediment, we can modify some element like cadmium, for example, to become, for example, more or less mobile, depend of the oxidation condition.
Okay, thank you. Now we go to the chat. This is there are question from Ali. Hydrocarbon removals. Which kind of polyaromatic hydrocarbons did you use? Like the
I use
simple naphthalene or the complex mixture? Were there any tendency that electrochemical remediation method was better than polyaromatic hydrocarbons than the complex multi-rings of polyaromatic hydrocarbons? How about long chain alipatics and remediation?
Yeah, I see.
You
I
get
see
it?
that.
You can see in the chat.
Yeah. I see the first point, and I like to give more detail about that. We focus about the 16 element fixed by the American Agents of Health like toxic. So we use from the simple to complex. So we have the lower, the middle, and the heavy organic compound. So we have the 16. We have the three kind of family, if I can use this word. And what we make it, I see for me, the treatment, it's work for any kind of heavy lower. But when we apply the electroosmotic flow, the simple molecule, it's more easy to extract first. So the long and the complex, it's take more time, that's all, but it's extracted. The main point here is about the concentration of the surfactant we use. So why we use fifth time the micellar? Because when we add surfactant in the soil, we will lose some part of this surfactant by another kind of degrade thing. Or so why we put 5 times. And when we have the micelle, it's take all the three kind of organic compound, simple, middle, and heavy. And I still remember in the first days, we are able to extract quickly, for example, the simple compound. The heavy, it's take more time, but it's extracted also. This is concerned the first point. If it's okay, I can go for the second point. Let me know.
Okay, go to the second question. Since polyaromatic hydrocarbons oxidation often may lead to the emergence of more toxic compound, rapidly bioavailable, thus how long the oxidation process are needed? So those polyaromatic hydrocarbon derivatives suggestion with this case.
Okay. I know in some literature, some people, they use oxidation condition to degrade or to modify the structure of the organic compound. In our case, we don't use this. And when we give a recommendation for the local authority, when we dredge exactly and directly the sediment, we ask them to put it first in some deposit area. We control the compounded initial and during the time when it's stay in the chamber or in the deposit area. And to be honest with you, I didn't find, for example, some kind of about degradable compound, organic compound. I don't remember we see that. So why when I look for the oxidation process, for me, I didn't really see that happen between dredging, deposit, and when we start the treatment. And from starting the treatment, we don't give oxidation. We don't work in the oxidation process. I like to make it more clear. The electrokinetic, what we use it, we can use oxidation. But in my case, we don't use oxidation, and we control some condition to try to don't affect our medium. And if I will affect the initial compound organic, in my opinion, I affect my medium also, because I like to keep the initial and the final quite similar.
Okay.
If it's not clear, I can reply again. Huh?
Yeah.
But in our condition in the lab, we don't work about oxidation. We control this parameter. We don't use it.
Yes, you didn't use oxygen, aeration,
Yes,
something like
yes,
that.
yes.
Okay, so
When we apply the electrokinetics, yeah, for sure, we generate some oxygen, but it's happen in the chamber. I will share again my screen. It's shared, or
okay.
I will
Let's
share
see.
again.
Okay.
Look, I will when we talk about the setup and about the process, we are here. We are here. It's the principle. So the oxygen, it's really leave directly from the anode compartment. You see this area here, the anode?
Yes, okay.
Yes. So why I said the oxidation, we can make oxidation treatment, but we don't use it in here. For here we inject our molecule. For example, when we add the citric acid here, this citrate molecules, it's negative charge, so she will migrate into the anode. This is the process we use. And when we use the tensioactive, we use it to reduce the surface charge and to make the element more release. Like this, we can extract it by electromigration or electroosmosis.
Okay.
So
We
this
can
is why
move
I said
now.
it's in our case of study, we don't use oxidation condition. We control it, so we don't have it.
Okay.
I will look now for the third question. The third question.
Okay, I will read it.
Okay.
How long the electrodes usually can be used for this technique until we have to replace them? How do we know when the electrodes have already been deteriorated? Please answer.
Okay, thank you. We use usually inert electrode, we call it. We can use platinum, we can use graphite, and usually we use graphite electrode because it's the most cheap and it's inert, so we can use it. The electrode science, really, we have a lot of study and we have some commercial good electrode can resist in different kind of medium. We have even electrode, we can use it, it's kind of plastic. So in this kind of science, really it's so developed. And in China, they have a pattern about some new kind of electrode can be used. And it's so safe and inert and can. For our experience in our lab, we use graphite. And the graphite, it can be corroded a little when the pH, for example, become close to 2 or 3. But in our condition, we try really to maintain pH. I will said healthy pH for me in the treatment means the pH it's between 3.7. It's around 4 to 5. So it's not really a big challenge to use electrode. Okay. And if we use platinum, for example, it can stay for long. In our case, when you use graphite electrode, we can use it for 2-3 years, different experience. When we change it, when we surface and the geometry of the electrode is corroded. Why? Because the density of current need to be and to maintain in the experience. When we modify the density current, in this case, we change the electrode.
Okay. Is there any question from the floor? Okay, before someone raised their hand, I would like also to ask you about citric acid. Is there so many acid? Acetic acid, yeah, malic acid. Why you use citric acid? It is because of the availability or what?
No, because we have different kind of agent or gelatin agent. We use it because he work well, like it make complexation with the metals. And we use it for two reasons. One, he's friendly for the environmental.
Okay.
Okay. Second, it's a cheap and the citrate we can find it already in the soil.
Oh.
Okay,
Yes.
the molecule we can find it in the soil, so and there is many study about the impact of bio effect and the health of the soil when we use tensioactive or citric acid. So why we keep combine? But usually, in previous study, we work with different kind of gelatin agent, different acid, different tensioactive. So for example, we use NTA, we use EDDS, we use EDTA. But we keep using citric acid because really it cannot give any kind of trouble for our soil. So it's make it healthy.
Yes.
And another point, we need to think when we use molecules, this molecule, for example, don't cost a lot of money.
Yeah.
Like the surfactant between 20 or 80. It's so cheap and we can use it.
Yes. There are twin 80 and twin 20. Which one is better?
For me, I would said 80, okay, because
Yeah.
it's more cheap and we find better result with the twin 80.
Okay.
Yeah, we find better result. But I will said in some case, the difficulty in our study, when we change the medium, we change the if any kind of fraction, so the treatment can change.
Yes.
So for me, I will keep saying always 20 or 80 for me. It's keep working and give good result really.
Okay. Thank you, Dr. Ammami. Ladies and gentlemen, is there any question? If there are no more questions, we thank to Dr. Ammami for the nice presentation. And we're looking for the next joint experiment and joint proposal might be.
Oh, kita nggak jemput kan? Oh, namanya jemput ya.
Hello, Pak Joko. Would you like to ask?
Jam 3. Sementara jam 3 kita tambah di rumah.
Halo, Pak Joko. Okay. Now the time is 5 minutes to 15 in Jakarta time. I think this a nice presentation from Havre-University. Our distance is about 12,000 kilometers. So
Wow.
there are so many hindrances in the some signal trouble. Also, I hope all of participants could get the benefit of the meeting. I would like to invite Dr. Hanis Ambarsari. She give the closing.
Okay. Okay, thank you very much. Alhamdulillah, we have finished our environmental talking about the electrokinetic remediation. Thank you very much for your presentation. It's very insightful. Dr. Mohamed Ammami and also Professor Benamar. Hopefully we can collaborate more intensively in the future about this topic. It's very interesting and we are still hoping that we can get the funding with our research from the Indonesian government as well as the French government in the future. Thank you very much for everybody in joining this event and hopefully we can see again in the near future. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you and Assalamu alaikum.
Assalamualaikum.
I hope we can meet physically next time.
Okay, Dr. Ammami.
Okay, thank you very
See
much.
you.
Shukran.
Terima kasih.
you.
Leave.
Bye-bye, everybody.
Bye.
Terima kasih. Salam sehat.
Yo.
Assalamualaikum.
Terima kasih Bapak Ibu semua. Terima kasih. Maaf lahir batin kalau ada kekurangan ya. Terima kasih semuanya. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Izin live ya.